My name is Daniel Padilla Ochoa. I am the Urban Ocean Project Director, working within Ocean Conservancy, a partner very closely with the Resilient Cities Network and the Circularity Initiative to implement the Urban Ocean program. Urban Ocean is a first of its kind jointly implemented initiative by Resilient Cities Network, Ocean Conservancy, and the Circularity Initiative, and we aim to achieve systemic transformation by working with leading cities and partners willing to invest in change and scale. Next slide, please. As you can see in this map, the Urban Ocean Network is growing and is extensive within the two continents of Asia and Latin America, South America specifically. And what the program really is trying to do is be a capacity building and accelerator program. We're trying to enhance the understanding of ocean plastics challenge and really start speeding up the understanding and the implementation of the circular economy principles and address waste management situations in selected cities to ultimately support them to develop financiable strategies and projects designed to address the interrelated challenges that they identify. And so the first thing is we really seek to understand what the context is locally. And then from there, we want to identify the opportunities and the priorities that each city government wants to tackle. The program provides a platform for then cities to showcase their leadership and share their knowledge and experiences across the Urban Ocean Network and beyond. As a key partner in this, the Resilient Cities Network, within the context of what it means to be a resilient city, is a fantastic platform from which this urban ocean cities share out their work and learn from one another. Next slide, please. A fundamental and indispensable partner really has been the University of Georgia's New Materials Institute. We're going to go through a lot of names that are related to University of Georgia. I'll refer to it from now on as UGA. And Urban Ocean has been working with UGA since the program started in 2019. And jointly using their Circularity Assessment Protocol, or CAP, we have collected data from 12 cities across 9 different countries. Taking a macro look at the data, we have unearthed trends on the most commonly found litter and packaging materials sold in stores across the 2 continents. By partnering with UGA, Urban Ocean has set a precedent in working with cities across Asia and Latin America to reshape the way cities think of waste management, their power to cut emissions related to the production, transportation, logistics, usage, consumption, and end of life cycle related to waste management, and the opportunities that lie ahead of moving away from single-use plastics and single-use materials altogether and go away from a linear consumption model towards that circular economy. Circular economies, the way that we imagine them being implemented in cities, offer a set of tools to reduce your global emissions, strengthen economic, social, and environmental health, and spur innovation that works with sustainable living in mind. We're really after that triple bottom line and really after trying to visualize and bring to the front the true impacts of a throwaway economy. Next slide, please. It's my great pleasure to introduce these 2 phenomenal and impressive people. Both Taylor and Jenna have been key partners in implementing the Urban Ocean program. Not only is it really their brainchild, but in addition to that, it is a work of passion. I'll start with Taylor. Taylor Maddalene currently is a PhD candidate and director of the Circularity Assessment Protocol at the Circularity Informatics Lab within the University of Georgia. Taylor received her bachelor's in environmental science from the University of Virginia and her master's in marine biodiversity and conservation from Scripps Institution of Oceanography at UC San Diego. Her background is in marine ecology, conservation, and science communication. Working on projects in marine science and ecology, conservation, and science communication, she's been partnering with organizations across the globe, such as National Geographic, NOAA, and RARE. Her current research focuses on the impacts of plastic pollution on coastal ecosystems and tying human behavior and waste management infrastructure on land with what we find in the ocean. As director of CAP, Taylor works very closely with us in the Urban Ocean program to understand how local contexts might alter the way we study circularity in each city. And she'll share more about that in a minute. Once we have key findings from each city, Taylor participates in the workshops that are hosted in each city to present the findings and help shift the way cities think about waste management and the transition to a circular economy. Welcome, Taylor. Dr. Jenna Jambeck is the Georgia Athletic Association Distinguished Professor of Environmental Engineering in the University of Georgia College of Engineering. In 2022, Professor Jambeck was named a MacArthur Fellow for her work investigating the scale of plastic pollution and galvanizing efforts to address plastic waste. Jenna is internationally recognized for her research on plastic waste in the ocean and for the Marine Debris Tracker app, which she co-created with fellow UGA faculty member Kyle Johansson. Professor Jambeck leads the Circularity Informatics Lab, that lab that hosts the CAP, which Taylor then is the director of. Using the concepts of the circular economy and green engineering principles to examine materials and products along their entire value chain. And so they're really looking at how materials are not just conceptually made and then designed, but then how are they then interacting with all of the systems that require those materials to then reach their final point. She has over 26 years of experience in solid waste management and 23 years of experience working directly in marine litter. Please join me in welcoming Taylor and Jenna. We are very excited to hear more from your insights across what the implementing the work of CAP across the globe means and some of those patterns and interventions that we hope would be implemented and scaled through Urban Ocean. Welcome, Taylor and Jenna.
Thank you for the wonderful introduction, Danny, and thank you for having us here today. It's a pleasure to have the opportunity to speak with you all more about the Circularity Assessment Protocol, and importantly, how you can use it to help inform decisions in your own local context. Dr. Jambeck and I will be going back and forth throughout this presentation, and I am going to go ahead and kick us off with a bit of an introduction to CAP, but also a bit of background on why we landed on this type of tool in the first place and why this type of research is really important and pertinent to cities around the world right now. So why do we care about plastic specifically, or why do we care about the overconsumption of materials in the first place? So not surprisingly, when we're using the CAP, we're often looking at single-use plastic. We can use CAP for any material type, but for the purposes of the urban ocean research and what we'll be discussing today, we're specifically looking at plastic pollution. So this graphic shows plastic production over time and how it's really grown exponentially since its conception in the sort of 1950s. Importantly, the largest proportion of plastic manufacturing, which is shown in hot pink at the bottom of that graph, is packaging, which is most often single-use items designed to be used by the consumer for less than 10 minutes before being discarded, and then are not intended to be durable or long-term materials. So there's a mismatch between what is made and how it's handled at the end of its life. And we've designed more and more complex materials at a faster rate than infrastructure and societal norms have been able to keep up with. There are thousands of different types of plastic polymers and another scale more of additives that can go into those plastics to take on different characteristics. And so we've designed ourselves into this situation where what we're producing does not match the way that we can manage it.
So another way to look at this data is on a cumulative scale. So the graph before was annual, but in 2017, we published this research and showed that between 2050 and 2017, a cumulative 8.3 billion metric tons of plastic had been produced for use. And as you heard from Taylor, the majority of that has been produced and used in packaging and single-use items. So that meant that 6.3 billion metric tons had already become waste. Now, what makes plastic useful in so many applications, and you heard some of that from Taylor, but it can be any color of the rainbow. It can be flexible, rigid, various additives give it different properties. And so that usefulness, though, and that variety means that it's very challenging to recycle in many cases. And so globally, at this same point in time, we estimated that only 9% of plastics had been recycled. While there was also a small fraction that had been incinerated, that meant that 79% of plastics had either ended up in a landfill or worse yet, in the open environment. I think you're on next, Taylor, for the next slide.
Yep. Got it. So we now know, importantly, that plastic and its associated chemicals also affect human and environmental health throughout the whole life cycle. Plastic particles and the chemicals associated with them, many of which are known carcinogens and endocrine disruptors, have been found in the air above Mount Everest, in the deepest parts of the ocean in the Mariana Trench, and even in human blood and human tissue. And importantly, plastic pollution has also become an environmental justice issue, as these negative effects across the life cycle are disproportionately felt by marginalized and disenfranchised communities worldwide. So the issue has become inescapable and ubiquitous. It's something we can no longer ignore, and we know that it is intrinsically tied to economic resilience, societal resilience, and environmental resilience. But importantly, we do believe that this is a solvable challenge and one that does start from the ground up with cities.
And now we want to talk a little bit about circularity. I think there are some misconceptions on what circularity means, and so we do want to better define that for this webinar today. So first of all, we can think of circularity similar to what we see happen in nature. Every output becomes an input in nature, and really the concept of waste overall becomes obsolete. I think another way of looking at this is to say that we don't want to create outputs that can't be an input. And that again would create a very circular system. One of the misconceptions that I was talking about is that circularity is not just recycling. Recycling will play a role in circularity, but you must have this integrated approach with a systems change upstream. And what I mean by that is that really you can have highest forms of circularity where you create no waste in the first place. And then that can relate to a reuse, refill, or a service economy. All those are examples of circularity beyond just recycling. And then when we look at cities, we know that cities are complex systems. And so as a complex system, a city can actually optimize their circularity. Next slide. So thinking about how to optimize that circularity, when we look at how plastic ends up leaking into the environment, we can look across its life cycle and think about interventions at various stages. And I also sort of wanted to define upstream here. So in this case, when you're talking about earlier in the life cycle, that's what we mean by upstream, and that would be points 1, 2, and 3, where we're looking at reducing how much plastic we use in the first place, replacing it with innovative materials and looking at redesign of products and packaging, and then reducing the waste that we're generating in the first place. But we also need interventions downstream, and those would be things like improving our waste management systems to capture more of the plastic, keeping it out of the environment, capturing plastic once it has entered the environment, but keeping it from getting into the ocean where it's extremely hard to capture. And so that can also reduce our quantity leaking out. And so that's kind of what we're defining here. And in the US, we're using the strategic framework to look at interventions across the life cycle here as well. Next slide. So now I want to introduce the Circularity Assessment Protocol, our CAP, we've been calling this. And this protocol was really born out of questions around plastic pollution solutions. And I think after some of our research was published in 2015, this started a conversation about the circular economy and how the circular economy could translate to the reduction of plastic pollution. However, what I was also seeing as I traveled the world and was working with the State Department, visiting cities and countries around the world, was that that's where decisions about waste management and various community decisions were made. And so when I was speaking with people, and we were talking about plastic pollution, they said, well, what do you think we should do? And so really to say, oh, the circular economy is a solution, it's an abstract idea. And so thinking about what the circular economy really means on the ground in a city became quite important. I also was like, I'm not the expert of your community. You have the knowledge, you have the expertise to know what might work in your community. But what was lacking in many cases was data. And so as I thought about looking around what could be collected in terms of data in a community and what could contribute to decision making, I was looking at what is for sale in stores. What are the knowledge and perceptions around this issue? How are items packaged that are for sale in stores? Are there reuse versus single-use systems? And then, of course, looking at the waste management system as well, separating collection and final management of the material, because oftentimes collection is one of the hardest parts, and you might have a technology for treatment, but if you can't get the material collected, then you can't really use that technology. And then finally, what ends up in the environment can indicate what can be a clue to what we can maybe do upstream to prevent that item from leaking out in the first place. And Taylor will give some more details and example results of all of these spokes, but this is a hub and spoke model. And next slide, we have a map. We have collaboratively conducted CAP. And this is a collaborative approach working with local implementation partners, the cities themselves. And this has been in 56 cities across 16 countries around the world. And next slide, as I mentioned, we work with local implementation partners. So typically, we train folks that are local. They bring their knowledge to the table. We talk about the methods, and they get virtual training to be able to perform all of that field work and data collection in their own local community. Of course, time is compensated as well. And so that becomes an important component of the CAP that involves the local partners. And I think you're next, Taylor.
I'm up.
Back.
So as Danny mentioned, University of Georgia and our Circularity Informatics Lab has been a partner of Urban Ocean since its inception. And early on, it was decided that CAP would be a useful tool for cities to go through at the very beginning of their urban ocean journey to set a baseline. So to understand the current state of their waste management, of their pollution, of their materials management. And from there, they can identify solutions and get guided through the rest of the urban ocean process. So what I'm going to talk through next is a bit more detail on what some of those findings have been for each of those CAP spokes, but also dive into one particular study that we did where we looked across all 6 cities in the first cohort of Urban Ocean. And we developed a publication looking at a meta-analysis of all of that data and pulling out some of the trends that came from that. So first off, I'm just going to go into a little bit more detail of the different spokes of CAP that Jenna just mentioned. So as we said, the CAP was born out of a need to understand what circular economy actually means on the ground, what it looks like at the city scale, and how do we measure it. And as I said, this can be done with any waste stream. We're in the process of also looking at things like construction and demolition debris and food waste. But for the purposes of Urban Ocean, we're looking at plastic pollution, as it's a critical concern for many cities around the world. So there are 7 different components or spokes of CAP that combine qualitative and quantitative data to give a snapshot of a city's circularity at a point in time. And then that data can be used to inform which spokes need to be focused on to help inform interventions to create a more circular system overall. So starting at the top right, the first spoke is input. So input looks at the products that are sold in the community and where they originate. And this is done through store surveys. So surveys of both grocery stores and convenience stores in the city. Community looks at the conversations that are happening and what are stakeholders' attitudes and perceptions around waste and materials. And this is done through semi-structured stakeholder interviews in the community. The next is product design, which looks at what are the materials, formats, and innovations that are found in products, particularly packaging. And this is again done through convenience store surveys, grocery store surveys, and also surveys of restaurants and food vendors to look at to-go materials. Use looks at community trends around use and reuse of product types, seeing if there are bulk purchase options, if there are reuse and refill options. And this is done through both store surveys and the stakeholder surveys, or stakeholder interviews, excuse me. The next is collection, which looks at how much waste is actually generated and what does it comprise. Ultimately, how is it collected? And what type of infrastructure exists for that collection. And this is done through literature reviews of existing policies and practices, but also site visits and stakeholder interviews. The next is end of cycle, which we intentionally call end of cycle instead of end of life, because we want to perpetuate that this is a cycle and not the last stage of this product's life. And this looks at everything that happens after collection. So what is the fate of waste once it is properly discarded, and how is it treated? Are there landfill options, recycling, composting, incineration? And this is done through, again, literature reviews, site visits, and interviews. And last but certainly not least is leakage. So this looks at everything that ends up escaping that system and ending up in the environment. And for every bit of litter that we find, as Jenna said, this can serve as a clue. So we ask ourselves, not only what is it, but why and how is it getting there? What are the enabling conditions in the other part of the system that are allowing for this material to end up in the environment? And this is done through randomized litter transects. And we use an app called the Debris Tracker, which is something that was developed at our research group. It is free, open source, and anyone can use it to track litter in their own backyard. I'll talk a little bit more about that later. So this is the paper, the publication that I mentioned, where we did a meta-analysis across the first 6 cities of the first urban ocean cohort. And we had co-authors from all of the funders and partners in this project, as well as all of the local implementation partners from the 6 cities that were involved. And we'd be happy to share this. We can drop the link in the chat for this publication as well. So Danny did a great introduction to what urban ocean is. And it really does take cities through a process of mapping out challenges, risks, vulnerabilities, and opportunities, and then helping to develop an integrated approach of tackling not only solid waste management, but larger societal issues around resilience and how circularity ties into that. And as I said, CAP is the first port of call. It's the first process that all cities go through to set a baseline and get a handle on mapping those challenges, risks, vulnerabilities, and opportunities. And as Jenna mentioned, we do this through what we call our local implementation partners in each city. And Urban Ocean was first launched, or our first cohort was launched in 2020, which was a particularly difficult year for traveling. So it actually created the perfect opportunity for us to set up a remote training platform for CAP. And we worked with local partners in nonprofits and academia in Panama City and Panama, in Pune and Chennai in India, in Kanta in Vietnam, in Semarang in Indonesia, and in Malacca in Malaysia. So I won't be going through all 7 spokes. I'm just going to hit a couple of the highlights, but the paper does look at all 7 spokes of the meta-analysis. So just starting with input, we documented over 1,300 convenience products across all of the 6 cities. And what we looked at is where they were originating. So what is the brand? Where's the manufacturing location? and where's the parent company location in relation to the selling point. And we're able to create a figure like this, which from a very visual standpoint demonstrates where there are opportunities to have conversations with brands and with the private sector around enhancing circularity. So for example, you can see that Semarang and Pune especially had a lot of locally manufactured convenience items. Across all of the cities, snacks and chips were often manufactured really close to the location where they were sold. And so this could lead to conversations around, for example, extended producer responsibility or deposit return systems, whereby you work directly with those brands that have a large footprint in the city and say, are there ways that we can rethink how the packaging is recollected or how the packaging is designed? Because we know that it's being sold in our communities and we know that it could be a problematic material type. So there's lots of interesting private sector engagement opportunities that come from the input data. Next is product design. So we sampled 470 to-go products from 150 restaurants and food vendors across all cities, and in addition to the 1,300 convenience items. Not surprisingly, convenience products were dominated by multi-layer plastic in each city, and it was also the highest percentage across all of the cities. Now, multi-layer plastic is typically very lightweight, which makes it difficult to collect and hard to recycle, especially with the multiple layers and adhesives in between those layers. It also often has a really low value in the formal and informal recycling sector. So there's not a lot of incentive for it to be collected and recycled. When we look at to-go products, they were again still largely dominated by different types of plastics, but it varied very heavily across the cities. And one important thing to note is that cities where there were either product bans in place or anticipated bans in the coming years, there was a higher diversity of material types. So we're seeing cities that are piloting things like compostable plastic or bamboo or wood or paper alternatives, which could suggest that they're transitioning away from that single-use plastic, and it could be a really positive sign. Lastly, I'm just going to do a snapshot of the leakage data. So we documented over 27,000 litter items across all of the cities using those randomized litter transects and the debris tracker app, which again, I encourage anyone to look at. It is free and open source and a really easy way to track litter in your own city. We saw some striking similarities, especially among the Southeast Asian countries. A lot had the same top items, especially tobacco and food products. Cigarettes and plastic food wrappers were among the top 5 most common litter items in all of the cities. That said, there were also distinct, unique items. So for example, there were more tobacco sachets in Pune, where that type of chewing tobacco was more common, as opposed to the cardboard and plastic cigarette cartons that are most common for cigarettes in other cities. So this litter data tells us what the most problematic items are and what's most likely to end up in the environment. So this can help us target them for interventions. And in terms of waste management systems, one key learning is that waste and collection systems look different all over the world. But unanimously, what goes into that system has to match the capability and capacity to manage that material. Otherwise, it's likely to end up escaping the system and end up as litter. So we saw a lot of different types of solid waste management, but quite universally, there was a need to divert away from landfill, to increase recycling, to increase composting, and also to build out critical infrastructure for collection, especially for things like cleaning, sorting, and transport. Another key finding was the value of the informal waste sector, which was found to be critical in all of the cities that we worked in, especially in terms of increasing collection, reducing leakage, and adding value and end markets to specific types of litter. And often that would even dictate what did or did not end up leaking into the environment. So we did a great meta-analysis looking across all of the cities, but the most important part coming out of this paper was doing a comparative analysis and seeing what type of interventions might have the biggest impact on circularity. So we used the 7 spokes and broke the data into 25% increments, and looked at how different interventions would impact each of those spokes, moving towards a circular system. And the key takeaway for us was that we were able to quantitatively and visually demonstrate the benefits of upstream interventions to optimize circularity. So as Jenna was saying earlier, those are things like looking upstream towards redesigning products, or having conversations around extended producer responsibility, redesigning the system before it actually reaches consumers and before it reaches the waste bin. So those tend to impact more of the cap spokes for circularity and have a higher degree of change towards optimizing circularity as opposed to downstream interventions. So for example, if you were to just eliminate cigarette litter, or if you were to just capture litter once it's ending up in the environment, you're really only going to impact one of those spokes for circularity. So this was a really critical takeaway for us, and something that was a key learning for cities in designing their proposals for optimizing circularity. And Urban Ocean provides a really fantastic pipeline for those CAP findings to directly inform the opportunity assessment that comes out of Urban Ocean. So this is the collaborative workshop, stakeholder workshop at the city level that talks through what are those key findings and what do we want to pursue at the city level. And then this year, we also had our first Urban Ocean Summit, where all of the cities that have participated were able to come together, share their findings, and also discuss the next steps in their proposals. So it's provided a great opportunity to have a shared data, shared definitions, and a shared nomenclature around circularity, and building out that network of learning across cities and contexts has been extremely valuable. And we're now just about to finish up our 3rd cohort of Urban Ocean. And we are looking to the next cohort, which should be an exciting one. So an important part of this webinar is discussing not only what data is collected, but how you can use that data to inform interventions at the city level. So we're going to talk briefly through some of the example interventions that cities have chosen to pursue based on this data. So these are the titles of the interventions, or the projects that were pursued from the first cohort of cities of Urban Ocean. Many chose to capitalize on the value of that informal waste sector to encourage community engagement, especially in waste sorting and processing. One of the key findings for a lot of these cities was the value of just separating dry and wet waste and having a mechanism for doing that at the household level. A lot of cities also recognized how circularity is tied to resilience and sustainability at large, and creating green job opportunities, because there are some fantastic job opportunities that come with building a more circular system. Some cities took a policy approach and were looking to build on existing policies, especially that were focused on problematic items. So looking at that litter data, the store data, and management data, seeing what doesn't necessarily match and saying that's the material type that we want to create a policy for. So for example, things like plastic film that are coming into the city, but there aren't a lot of opportunities for collection and recycling, and we know that they're ending up in litter. There were also some really fantastic smaller scale pilot programs for creating entire neighborhoods that were zero waste, or entire proof of concepts for sectors that were zero waste that can then be scaled. So there was a great diversity across the first cohort of Urban Ocean cities. And I think all of them did a fantastic job at using the CAP data and the other information collected through Urban Ocean to make scientifically informed decisions about what they want to pursue.
And then we have some other cities that we want to talk about in terms of interventions that were outside the Urban Ocean program. but might help inform ideas on what CAP can be used for. So we have a cohort of 4 cities in the United States, Ann Arbor, Hilo, Galveston, and Savannah, who know that they want to put in a reusable foodware system, but they wanted to conduct CAP to get a baseline before they put in this system to see how it would improve circularity. We also work in small island states. So there we are working in an environment that is more than just one city. But for example, in the country of Aruba, they are conducting CAP as well as looking at both procurement and import of products and materials, and then as well as export of materials. And they are considering a national extended producer responsibility policy. So another policy example. In the country, small island state of Dominica, they are using the CAP to generate their first ever national action plan for marine litter and reduction of plastic pollution, and looking at how to improve their waste infrastructure. In a couple of other US cities, Cape Girardeau and Blytheville, the mayors have been able to use the CAP data to talk to a national audience here in the United States to share the story of their communities. Both of these communities have a lack of recycling infrastructure. Blytheville is going to be working with a private company in the US called Replenish, but both of them have been able to share the challenges and their stories at national meetings, plastic pollution summits, and areas to talk about the problems that still exist, especially in rural communities. In Athens, Georgia, where we are located, we conducted a CAP and then a community compost collection pilot. So this was a curbside collection pilot. We do have drop-off centers for compost, but similar to what Taylor talked about in terms of separating wet and dry materials, our quantity of organics is a little less in the US, but getting those organic materials out of the waste stream and into a compost stream is much better. And also, if you are using alternative materials that are compostable, you need to have a compost system. Athens, Georgia is also looking at policies, including a restriction, including a ban or tax on plastic bags and extended polystyrene. In Miami, Florida, they're using the CAP for, it's not written here, but they were looking at installing stormwater catchment devices. They had a lot of stakeholder working groups and identified opportunities to explore creative and future policies because there is a ban on plastic bans in Florida. And so communities can get creative about offering incentives for restaurants to go green and reduce the use of single-use plastics that way. Next slide. The other thing we hope that will happen from CAP is that we can create a larger systems change with circularity, with materials management, reduce plastic pollution from the ground up. And so we want to talk about how that systems change can happen. Next slide. One of the ways we can look at this here on this slide to see how the systems changes can occur when CAP is utilized. You can see there's a lot of components of the city that can be examined for interventions, transportation, input of those materials, and then also trying to help link cities and communities to best practices, linking you to each other to communicate lessons learned. Other advantages of utilizing CAP is that you can adapt to local contexts, and I'll talk about some of that on how we can match cities up on some of the next slides. I think the other thing that CAP can be utilized for is sort of continuous improvement, or looking at it as a very holistic assessment to start. And then if you implement some interventions, then you can either do individual spokes to see how those interventions have impacted individual spokes of CAP for circularity, or eventually you can do another holistic assessment. Next slide, please. So this is what I was talking about in terms of similarity. So we can adapt a bit to local context. So the CAP will always be sort of this baseline assessment. But for example, if a community has a large tourism industry or fishing industry and really thinks that that industry can both participate and or amplify circularity, then that industry can be included, for example, in stakeholder interviews and some of the data collection as well. So you can imagine there could be some of these factors that it could influence where cities are alike and where cities are different. So creating this Venn diagram of some of these factors. So in some cases, you might group cities by geography. For example, we referenced sort of the group of cities that were in Southeast Asia. And seeing some of similar litter trends. Also, the land area of a city. Some are very small, compact, and highly dense. Some of them take up a lot of area. I think we've seen differences between rural and urban areas as well. So again, these archetypes are forming as we conduct CAP collaboratively with more cities moving forward. Next slide. Another thing that's come up a lot is the manufacturer and parent company locations. A lot of cities are starting to talk to manufacturers and parent companies about extended producer responsibility. And so thinking about if both your manufacturing and parent companies are fairly local or near you, that might be a different conversation than, say, if your manufacturer is local, but your parent company is very far away. And so you can see some different scenarios and how that conversation might go and how that might impact how circularity might be approached in your community. Next slide. So we want to talk a little bit about some next steps for CAP. So we are working on some various projects. Next slide. So our training for CAP has been typically through Zoom. And so we've done these live with each one of these cities that has had a local implementation partner. But what we would like to do is make this a bit more efficient and maybe more flexible for those taking the training. So we're going to put our training modules and courses into a platform so that they can be accessed asynchronously and autonomously, although we plan on having live interaction with us through office hours and various other scenarios. Next slide. This is just an example of one of the courses. So typically our Zooms for CAP training are around 2 hours, but next slide, please. You can see it's broken up into various modules, including sort of the training for each one of the spokes. And then the nice thing about a course like this, we can make the videos interactive. We can add animations and then documents that can be downloaded and read. And so it can be flexible and engaging through this platform. Next slide. The other thing we want to do is make the data available and interactive. And so through a data portal that is also open, similar to Debris Tracker, people can look at individual city data, compare cities to each other, look for those trends as I was talking about, and then even download the data to be able to create their own charts or utilize for, again, their own purposes and lessons learned. Next slide. And last, we're really interested in creating an intervention library across cities. So maybe being able to filter these interventions by those city archetypes could be a great way to look at this. But again, here's this life cycle slide that you saw at the beginning. There are interventions under each one of these scenarios. So for example, some of the more upstream interventions are going to be replacing single-use plastics with compostable alternatives. If you have the infrastructure, again, that's a conversation to be had. Maybe even a product design might be requiring caps attached to bottles. These are just example interventions that various folks have taken. One thing is that extended producer responsibility, or EPR, what we're seeing is that even though that might be a policy related to waste management, because you have a cost on certain product designs or use of plastic, it catalyzes something called eco-modulation, where companies will change their product design because they want to avoid the cost associated with an EPR policy. And so that promotes an upstream change in packaging material and design. Other interventions, again, upstream to reduce waste generation in the first place, reusable foodware containers for like those cities that are participating in the perpetual program, installing refill stations and working with refill companies. So other things you can do are using smaller waste bins or a pay-as-you-throw program, meaning you're charged per amount of waste generated. And then downstream, you can improve infrastructure, look at optimizing waste bin placement for collection. And again, this is where EPR fits into potentially fund improvements in infrastructure and incentivizing recycling, which is still going to be a part of circularity. And then last chance for capture, really. So looking at stormwater drain catchment devices, of course, both riverine and stormwater drain catchment devices need to be properly maintained. Otherwise, you will catch a material and then it will be it will still be released if it's not removed from those environments. And so I think that's where we're wrapped up, but we're happy to take questions and have more discussion at this point. Thank you.
Thank you. Wonderful presentation, Taylor and Dr. Jenna. Really appreciate that. Really, really informative. One note about the data and the portals that they have shared is that this information that's produced from the CAP is eminently actionable. For us from the Resilient Cities Network, we use this information with cities all the time to produce solutions, and the way that they're structured, the cities are very thankful from the insights they can gain to actually produce solutions on the ground. So we appreciate both the work that you're doing and sharing this presentation. So as Dr. Jenna said, we're going to go ahead and start taking a couple of questions. So the first note is that we will be sharing the locations with the PowerPoint that includes the locations of both the urban ocean cities and also the Circularity Assessment Protocol, wherever that's been deployed. So the first question I would like to ask is how the data, this is a question from Vaishali Kushan, how this data starting from 1950 has been collected.
Yeah, and I think he was talking about the initial slide where the plastic production data. And so that was a collaboration with Roland Geyer. And that data was from Plastics Europe initially. And one thing I wanted to do, I think you all are going to drop in the chat, there's a link. Roland Geyer has kept that data or that sort of materials flow model up to date. And so he has made that data available if you're interested in creating your own charts or getting his chart on that data. But primarily that was Plastics Europe, but also combined with an additive database that we had access to as well. So it's not that plastics were not invented before 1950. They certainly were and certainly were in use, but that was the first year of actually that sort of statistical public data collection.
Wonderful. Thank you. Another question here is a little bit more profound. So this person actually, again, is focusing on green building material and construction practices and waste management. Thus far, he says the cost to reuse building materials is high because to save it requires manpower, which can be more costly than buying new material. How can we remedy this issue?
So I love this question, especially because we have a partner for we have the portal and the data portal and the training portal are sponsored by the National Science Foundation here in the United States for a project that they are funding to create those for us. And we have a partner at the University of Pittsburgh, and that partner, Melissa Billick, is specifically working on adapting CAP for construction and demolition materials in the built environment. So I think this attendee, you would be very interested in that. So we would love to get your contact information so we can share that CAP with you. In general, the cost, it's kind of similar to the plastics cost, right? Like it is more expensive to recycle plastics, and a lot of people use the virgin material because it is so inexpensive. And so it is similar to that. What we need to do is really value those reused and recycled materials, but it is more costly to do deconstruction than demolition, right? And so what we often see in some of the situations here is being able to sell those reusable materials. We have like building reuse centers and specifically sort of some nonprofits that really help to capture that material and can resell it. But it remains a challenge because it's definitely more costly, but we hope that as a society, we can start to show through things like the CAP and other greenhouse gas inventories that saving those materials, it benefits us beyond that cost.
I'll add on to
And
that,
there's-
Jenna. Oh, go ahead, Taylor.
Oh, I was just going to mention there's also a group that we've worked with in Atlanta that's thinking about the sort of upstream needs to enable that kind of system. So similarly, like when we think about plastic products, if they're made with one type of material and, with a cap that stays attached and with, less adhesives and, materials that are more amenable to recycling and repair and reuse, then that will also enable that system downstream. So there's some construction groups that are also thinking about how upstream in the process, we can design materials and design construction in a way that it is better for it to be, easier to be broken down, easier to be reused, and that kind of becomes the norm, which requires a larger systems change, but it does run in parallel to a lot of the conversations that we have around packaging and plastic too. Sorry, Danny, go ahead.
No, that was great. I love examples from Atlanta. I'll add that there's part of the norms, right? So in terms of creating the society that actually values the materials, like Professor Jambeck was saying, is really having the true cost of materials be reflected in construction practices, right? And so marble, let's say from Italy, shouldn't be cheaper than something that we can capture from a construction site local to your area, simply on logistics and then transportation, but also on the greenhouse gas emissions. And so part of this conversation really is about making sure that the transparency of costing and what that is actually bringing, not just in terms of CO2 capture, but also in the subsidized enterprises, right? Like if shipping fuel wasn't so cheap, we wouldn't be paying those prices. And so as a society, those norms need to reflect those true costs. And then in addition to that, there's also the performance part, right? So if you look at LEED certified buildings, if you have reused material, they'll end up giving you not just cost saving because of logistical kind of savings, but in addition to that, the building performance will be better off. And so with that, you come with like higher real estate market speculation, et cetera. So there are both ends of it on the kind of at market and in the planning and looking at how do you receive and purchase those materials.
Mm-hmm. Those are great points.
Wonderful. Thank you, guys. We'll take another question here. One last question. The question was asked in the chat about why there aren't any, why we haven't had any presence in Europe. Hand that over to the speakers.
Danny, did you want to answer this one?
Yeah, I'll answer from the Urban Ocean perspective.
Okay.
So we have mentor cities that are part of the Urban Ocean network. As the title of the mentor implies, that there's practices and exemplary practices that can be transferred over. What we found since 2020 is that a lot of those examples and interventions are really difficult to then place within a local context of a rapidly growing and developing city, such as those that we work with in Asia and Latin America. For context, the largest cities in Europe are about half the size of the largest cities in Latin America and about a third the size of those in Asia. And so in terms of scale, we're really talking about just completely different types of cities, and then the budgets, right? So there was a webinar hosted by Resilient Cities, I believe about a month ago, where we looked at the impacts of natural phenomena, so like weather events, and how cities are able to cope with that. And the difference between European cities and the budgets that they have for response management and a city that's in a rapidly developing region is tenfold, right? And so those capacities are different, therefore the interventions are different in terms of the funding scale. And then the last part I'll add on to that is the vulnerability of the population. In Latin America and Asia, we have a lot of folks that are really dependent on the recycling market in order to have their sustained income, where we don't have that occurrence or that phenomena as much in European cities. And for that reason, it's been really difficult to translate those interventions. With that said, we are always interested in having a European city be part of the Urban Ocean program as a learning city, as just as every other city, so that we can unearth those findings.
Yeah, and I would just say we also would very much support doing CAP. And I think this was a very insightful question because whoever posed it noticed that CAP is not just about seeing what you need to do to change a system. It's also about learning what's working, right? And so I think those are really important data points to gather, but we need to have a city want to do that and the resources to be able to do that. So we are always open to that as well from our team. One quick question from the chat, Malcolm, if I could just quickly say, someone asked about the course already, and they're not quite done yet. We expect them to be fully completed in early 2025. As I mentioned, those are under development through this National Science Foundation project. So again, I guess leave your email, or I know you guys have the registration list. Would love for folks to find out when those are complete, and we'll do that. And we have captured emails for folks who are interested in the C&D CAP as well, which is the same part of that project and kind of coming down the pipeline. It's been piloted in Pittsburgh and Atlanta, and so it's not quite ready for prime time yet, but it's getting close.